Okay, thank you for inviting me, and apologies for the delay, the technical problems. So I will start with my presentation. First of all, my name is Michele Gallo, and I work as an aquaculture engineer in Malta for Aquabiotech Group. So in this presentation, I will give you a brief introduction of what aquaculture is, why it's important, and what we do in Aquabiotech. What is land-based aquaculture, and what are the applications of photonics technologies in this sector. So we start from Malta first. Not everyone probably is aware of what aquaculture is exactly, so I will give you this simple definition. So it's the breeding, rearing, and harvesting of fish, shellfish, plants, algae, and other organisms in all types of water environments. So basically, it's farming in water. The reason why it's important is because mainly for food security, we need to produce more animal protein for growing populations. And regarding fish, fish are the most efficient animal to farm in nowadays. You can see these numbers that you need. You can basically feed the fish 1 kilo to grow for 1 kilo of body weight, while for a cow you need to feed 10 kilos, for example. The forecast is telling us that in the next future, the amount of fish that we will be able to gather through fishing will be less than the one that aquaculture will be able to produce. But how aquaculture is going to produce this fish, I will tell you a bit later. So I'll give you an introduction about my company. We are an aquaculture consultancy company based in Malta. We were founded 1998, and nowadays we are around 75 people from 25 different countries. We work, the majority of our projects are outside Malta, and we keep on growing exponentially. Even currently during this crisis, I think we have been hired some people because we still need more people, which is quite good. And we have a wide variety of activities in our company, from normal consultancy related to aquaculture, fisheries, and the marine environment, environmental impact assessment. We do education as well for school and universities. We have our own private research facilities where we have around 40 systems where we use for experimental research on fish, for pharmaceutical companies, feed companies, and any companies who wants to develop a product that has to be in contact with aquatic organisms in general. And then there is the department where I work, in which we design and build fish farms and R&D facilities related to aquaculture. Currently, we are working in several different research projects. The majority are European, but they are also based internationally. Our main project is high efficiency, and we have one of our partners is also part of this consortium, LATAT, and this is a big project that is gonna finish in 3 years. I will tell you a bit more later. We had project in which we were been testing materials to reduce biofouling in the water, or project in which we developed, for example, fish farm, low cost and locally sourced in Africa, like in VicInAqua. So how these fish are produced currently? We have different production systems in the sea and in land. So the first point, I know this seminar is about the pollution in the oceans. Well, the first option that we have is move the production of aquaculture inland. So working on the land-based aquaculture. And in this land-based aquaculture, we have different options. The one that we believe is going to be the future of this sector, and we are mainly focusing our attention, is what we call recirculating aquaculture systems, which is a system, is a closed containment system, is a control environment where the water of the where the fish are swimming is filtered in multiple stages. First, the solids are removed. Then the metabolites are converted. Nitrogen is converted to a less harmful form. The excess gas is degassed. any potential pathogen is disinfected, oxygen is added again. So by using basically this small-scale wastewater treatment system, we managed to recirculate up to 99% of the water of the system, which means that we can farm the same amount of fish of a cage system with like 10% of the water, more or less. And every waste that we produce can be collected and treated later on. In fact, there are several projects taking care of the waste from aquaculture farms. And this is very important because it gives us a smaller footprint. We avoid polluting the oceans, and we can also control the production in a different way because we control also the temperature, the oxygen, the level of disinfection of the systems, and we can farm a lot of species overall. But what are the applications of photonic technology in this sector? Well, the first one is data collection and monitoring. We build and develop these monitoring and control systems for water quality parameters and system parameters in general. So we constantly need to collect data about our systems and the systems of our clients where we build the farm outside. And for example, we need to be able to detect the water quality parameter with more precision. So we are trying to move towards optical sensor, for example, for oxygen or for gas. This gives us also a better control on the fish health and fish behavior. So by using, let's say, state-of-the-art camera system, we are now able to study the behavior of fish and understand from their swimming patterns, for example, if there is any infections or if the water quality is decreasing. In this way, we can act and anticipate any potential problem. We can develop a smart feeding technology or at least implement them. So you can see this is one of the systems we built recently. It's a salmon hatchery in Scotland for the University of Stirling. And this hatchery is provided with all insulated tanks because it's installed in an old Scottish shed. And you can see that every tank has a blue device on top. This is an automatic feeder. And this automatic feeder is connected to our monitoring and control system. So we can decide how much feed we give to the fish at every time. And we can actually integrate this feeding system with the camera system so we can decide when to feed the fish based on when the fish are hungry and not wasting any extra feed. LED lighting. We are working with few companies producing LED lighting because I mean, it's not very new, but light is also affecting the production of hormones in fish, sexual maturation in some species, for example, salmon. So it is very important to take care of the proper lighting, not only for the biology of the fish, but also for fish observation, because as we have to observe these fish in a tanks made of plastic or fiberglass, we need to be able to have the right wavelength, and we can also control the evolution and the growth of these species. Early diagnosis. Nowadays, the majority of the samples are taken from fish that are previously culled, but we are trying to develop the method now using X-ray machine, for example. So we just put the fish asleep for a short time, and we take a picture with an X-ray machine, so we can check, for example, if there is any malformation in the fish or if there is any internal problem. In this way, we avoid culling extra fish that are not needed. But in general, diagnosis is very important because there are many diseases that are threatening our production, our fish production. So if we have a, let's say, a way to detect them in advance before autopsy, then it will be definitely an advantage for our sector. We can also monitor bacteria in the biofilter using, for example, fluorescence in situ hybridization. In this way, we are able to understand how the bacteria community in our biofilter is growing, if there is any unwanted host. For example, nematodes are not welcome in our biofilter, and we can also predict how much our biofilter will be efficient in removing our fish waste. All these technologies in general are going to be used in the end to create an Internet of Things platform where we can basically use centralized systems to control the feeding, the pumps, the machine, the valves of the system, everything, the temperature, the oxygen injected. And nowadays there are several companies trying to develop the softwares. They are for fish farmers mainly, but we are also working in our R&D facility testing the same technology. In this way, we are able to have the complete control of our system, and we can also collect more data on a daily basis, which is in the end going to be used for interpretation. All these technologies, or a lot of these technologies, are already part of our Horizon 2020 project efficiency, in which we are testing a camera system for fish behavior during feeding, and we are also developing a new way of taking care of the feeding of fish and centralizing all the farming activities. Another application that we saw in our project VicInAqua, another Horizon 2020, is trying to solve the energetic problem of these systems. Clearly, by installing a lot of electronic devices, we will need power and electricity, and this is not always available everywhere. So apologies for the noise. So basically trying to develop new solar panel is giving us the opportunity to install these systems also in developing countries where electricity is not always available. So what's next in this field? How do we see the future? Well, in Norway, the future is a floating closed containment system. So we move the system from land base, we move back to the ocean, but we keep them contained. So we have a RAS system that is floating basically. And in this way, we can collect all the fishes, for example, and we avoid the pollution, but we use the ocean as a substrate basically. Another option is what we are trying to develop. We tried also in the past in Malta, is a floating barge. So using a commercial barge and building a fish farm on a barge. So everything is contained in this barge, and you can move your fish farms around the world. All this type of evolution needs a certain type of control and a certain type of technology, and I think that photonics technology can give us an important help in developing our technology and spreading around the world to reduce also ocean pollution. So thanks a lot for your attention. And if you have also extra questions, you can always send me an email as well.
Thank you very much, Michele. And apologies for the pronunciation of your name. These things happens when a Polish guy living in Spain is moderating a webinar in English. And yes, we do have questions for you. So from Pepe, can your photonic control system check the plastic microparticles in the water so to avoid fish eating them?
Well, in our type of system, we don't have plastic in the water because we use water that is pre-filtered. So this is, in this way, we avoid any plastic, any microplastic and heavy metals as well. So we do microfiltration when it comes to seawater, for example, because we work with both seawater and fresh water. We use microfiltration. So we don't have this problem. And this is one of the advantages as well.
Okay, and thank you for your answer. Next question from Pedro Martinez. What kind of system do you use to monitor bacteria contamination? Do you need monitor specific species or total bacteria count is enough? What are the major target contaminant species?
Okay, this is not an easy. This is a very interesting question. Not always easy to answer. Overall, we don't monitor a lot of bacteria apart from taking samples of our biofilm. We know what species we don't want sometimes, but mainly are not bacteria. We're talking about viruses or other microorganisms. We do not have a monitoring in real time, and we will actually would love to have. So if there is any technology, that would be good. There are studies on the entire microbiology of the water as well, particularly in Denmark, but we are still a bit far to, let's say, to be applied in the field. What are the major target contaminant species? Well, the contaminants are the ones that we have in the feed, that we commercial feed that we put in the system. There are no other contaminants. So in this way, we avoid having extra contaminants from the external environment, unless we are working with the pharmaceutical companies and we develop vaccine for specific pathogens, and then we actually know what is the pathogen, and we don't want to have that pathogen in our biofilter. I don't know if I answered the question.
Okay. So I think that yes, you did, and you have one more from
Okay.
Joachim.
Okay.
What is your role in the efficiency project, and what have been done so far?
Okay, we are the leading partner of this project, so we are coordinating the project, and our role, as we have a research facility, we are the testing ground for all these research related to fish feeding. So at the moment, we are waiting to open again the airport so we can start our experiment on alternative feed ingredients, and we can install our camera system in one of our systems that will be used for the testing during this project. But we are a lot of other partners from several countries, of which one of them is also part of this consortium, as I mentioned.
Mm-hmm. Okay, so thank you very much.
Thank you
for your presentation and for your answers.